In the previous lecture, we learned how to perform number system conversion. Now let us say we would like to write a computer program which converts a decimal number to its hexadecimal form. This program takes a decimal number as an input and produces the hexadecimal number. If the decimal 3492 is fed as an input, output should be DA4. You shall be capable of writing a computer program like this only if you are capable of converting any given decimal number to its hexadecimal form using pen and paper. Meaning, first of all, you should be yourself clear on how to convert a given decimal number into its hexadecimal form. Once you are clear on pen and paper, the next part in process of programming is to specify all the steps involved in converting a decimal number to its hexadecimal form. This step-by-step set of instructions for solving a given problem is called an algorithm. All instructions of an algorithm must be clear, precise, and unambiguous. Instructions should not be misleading. It should be to the point, doable, and with no double meaning. Writing an algorithm before actually coding is one of the best practices that good programmers follow. It gives you clarity and saves your time while programming. Now let us write an algorithm to convert a decimal number to its hexadecimal form. We shall follow the concept of dividing by 16 and noting down all the reminders. The first step, that is step number 1, is input the decimal number, say n. First thing first, we need to have a decimal number to be converted. Kavya has volunteered to trace this algorithm along with me.
Let me assume n to be 162.
Step number 2. Divide n by 16 and note down the remainder as r and quotient as q.
On dividing 162 by 16, remainder is 2 and quotient is 10.
Step number 3. Record the remainder r in the variable, say y. The variable y can hold multiple values.
Here the remainder r equals to 2 is stored in the variable y.
Step number 4. Check if quotient q is 0. If yes, go to step 5. Else, assign n as q, that is n equals to q, and go to step number 2.
Here q is 10, which is not equals to 0. So I assign n as q, that is n now becomes 10, and then I go to step number 2. In step 2, I divide n by 16, that is divide 10 by 16, remainder is 10 and the quotient is 0. Now I go to step number 3, record r equals to 10 in the variable y. Now go to step number 4 and check the quotient. And now quotient is 0, so I go to step number 5.
Step number 5. Reverse the variable y and store it as answer a.
Y is 2a and reverse of 2a is a2.
Step number 6. Display the hexadecimal number stored in the variable a.
a2 is now displayed as an output.
This is a 6-step algorithm. Step 1 takes the input. Step 2 to 5 does processing. Step 6 displays the output. Once your algorithm is ready, you must use it as a document to share your ideas amongst others, and later these steps may be easily converted into a computer program. That's all in this lecture. Next, we are going to learn how to represent this algorithm pictorially.